Okay, so now what we're going to do is we're going to name ionic compounds. I highlighted it in green up there to make sure you understood. There's a big section on this, okay? So here's the most important thing to remember about ionic compounds is they're electrically neutral. Now, what does it mean to be electrically neutral? Now, we think of like electricity as being like plus and minus and out of the wall of your house, but really that's all coming from gain and loss of electrons. So when I say electrically neutral, I'm actually talking about electrons. So all that means is pluses and minuses cancel out. If it's electrically neutral, there's as many positive charges as negative charges. So yeah, it means that the positive charges balance completely with the negative charges. Now, let's talk about the cations. You already know what cations are. Those are the positives and those lost, right? Lost electrons. There's two types of cations. In the older edition of the book, it was formalized as type 1 and type 2, and I just sort of stuck with it. Type 1 are the ones you already know. Remember I told you how you could predict the charge based on the position in the periodic table. So for example, we'll go back to our little periodic table. Oops, sorry. This guy here. And all the ones in group 1 are +1, and all the ones in group 2 are +2, right? And then this is +3, and then these ones here you can predict as well, and they're based on their group numbers. Now, silver's 1, remember that was 1b, but if you want to use the numbers that are up here, you just subtract 10 from them. So this would be 1, 2, and 3. All right, so those are the cations that are fixed charge. Now, having said that, there are cations, so right, fixed and predictable. There are cations that have many possible charges, okay? So I guess the way I kind of look at it from my personal life is when I was dating my wife, I wanted to sort of be a fixed charged kind of guy. I want her to be able to depend on how I was going to be. I was still a little spontaneous, but I was a type 1, right? Now, not all guys are like that, right? Some guys are type 2s. So, can't do anything about it really, but they're unpredictable. Sometimes their charges are different, sometimes they're the same. And so it turns out metals are that way. Some can be type 1 where they'll always have the same charge, and then some will be type 2s where they can have different charges. And that has to do with their electrons and how the atom is actually structured, and we learn a little bit about that later, but for now it's enough to know there's type 1s and type 2s. Now, how do you know if it's type 1, right? Well, you know the ones from the periodic table. How do you know it's type 2? Well, not type 1. That's the only way to know. So that's why it's important to know which ones you can predict and which ones you can't, and be certain of that. Now, anions, they are what they are. There's no type 1s and type 2s. There's monatomic and polyatomics, and their charges are always the same. Okay, so nitrate as a polyatomic ion always has a -1 charge. Nitride, the monatomic ion, right, always has a -3 charge. There's no exceptions to that. So the monatomic ones you can predict from the periodic table. The nonmetals, we talked about those before. And the polyatomics are the ones we just talked about. You memorize them, and there's a list on Canvas, okay? So now what we're going to do is we're going to use some of that information, and we're going to write formulas for ionic compounds that contain these elements, okay? And these are don't contain polyatomic ions. So aluminum, all right, Al, and oxygen, O. What we have to do in order to write the formula for the ionic compound, we have to figure out what the charges of their ions are. So I'm going to go over here, and we're going to find aluminum and oxygen, right? Now, you may be familiar, but aluminum was this top one here. So aluminum is +3. It's one of the ones from the periodic table that you can predict. Oxygen because it's 2 away from neon, is 2 minus. So let me go incorporate that information into what we've learned, or what we've written. It's 3 plus and 2 minus, like that. So how do you write the formula for it, right? Well, we want it to be electrically neutral. So I'm going to show you how to do it, and then I'll explain to you why I did it that way. I'm going to take the 2 that's with the oxygen and put it with the aluminum, and I'm going to take the 3 that's with the aluminum and put it with the oxygen. Now, if I have 3 plus, right, and I multiply it by 2, this gives me a total of 6 plus charges over here. If I take 2 minus and I multiply it by 3, that gives me a total of 6 minus charges here. So really, it's a cross multiplication that we're doing. And they often call it crossing the charges. And the point is to get to the same magnitude of positive negatives so that when you put them together, they'll be electrically neutral. Okay? Now, let's do beryllium and iodine. And just to speed this up just a little bit, I'm going to write this one out for you, and then I'll have you look these other ones up. These are all ones you can tell from their position on the periodic table. So beryllium is Be, it's 2 plus, and iodine is 1 minus, like that. Now you don't have to put the 1 there, but I like to put it there sometimes. I just feel like it looks better. Now, if I want to get an electrically neutral, right, what I'll end up doing is I'll go Be. There's a 1 here because there's a 1 here, but we don't write the 1 subscript. Now nobody's going to get mad at you if you do it, right? But you know, us older chemists will look at you with funny eyes. So anyways, then what I'm going to do is put I2 here, like this, because that's the charge on the beryllium. So what that means is I have a 2 plus charge here, and now I have a 2 minus charge here, and that cancels out because I brought in 2 of those. So that's the formula for beryllium iodide, and then we cross the charges, we just don't write the 1, okay? So this is what I want you to do is look up calcium and sulfur, and look up calcium and iodine, okay, so really just sulfur and iodine and calcium, and predict what the formulas are, and then I'm going to teach you another trick once you've done that. So I'm going to pause it, or you're going to pause it. I'm pausing it too, and I'm just going to write the answers. Okay, so those ones are done, right? So calcium 2 plus, sulfur 2 minus, Ca2S2. But here's the thing, when we do ionic compounds, we always write their empirical formula, and so this becomes CaS. And you could have guessed that because this is 2 plus and 2 minus, so to make it electrically neutral, all you have to do is bring the 2 together, right? They'll cancel each other out. So that's the empirical formula for calcium and sulfur when you take the ions and bring them together. Now, calcium and iodide is essentially the same as beryllium and iodide. They're actually in the same families, calcium and beryllium, so you expect their formulas to be the same, and they're the same. Okay, now, this is what I want you to do. These are all polyatomic ions, and you need to look these polyatomic ions up. And then, so I'm going to pause it. You look up the polyatomic ions, or try to remember what they are from what we talked about earlier. Hydroxide, you'll have to look it up, by the way. And then I'll write them on the screen, and then we'll go through the process of writing formulas for them. Okay, so here we are. Those are the polyatomic ion formulas. Hydroxide, you should have looked up. You should have found that fairly easy. Carbonate, phosphate. But this one, sorry, let me fix that. It's just bothering me. This one is hydrogen phosphate. And this is actually a little trick here. It's actually phosphate and hydrogen ion brought together. Remember, hydrogen's in group 1, so its charge is going to be +1. So if I take a +1 and a -3 and bring them together, I end up with a 2 minus, because one of those charges will cancel. So now what we're going to do is we're going to write the formula for calcium and hydroxide. Now calcium, we already looked that one up, right? It's right up here. Calcium is 2+. So if I'm going to write a formula for calcium hydroxide, you want to write it like this. Ca, this is a polyatomic ion. The temptation is say O2H2, but you need to keep the polyatomic ion formula unchanged. So you're going to say OH and then a 2 like that. Okay? So anytime there's an uneven number of ions, you have to use a parenthesis and a subscript. In general, if there's more than one, you use a parenthesis and a subscript. This is what it works out to. So carbonates 2 minus, right? So the formula would be CaCO3 like that. Now, you notice I didn't use parentheses. You don't use parentheses when there's only one. And that actually makes it more difficult because in order to see polyatomic ions, right, you normally have to cover up this first element. So you would cover this up. And then you see CO3. You don't see the charge, so you have to think to yourself, what does that formula look like to me? Oh, it looks like carbonate, and then you recognize that that's carbonate ion. So it's a little bit harder because we didn't put the parentheses around it. Now, for hydrogen phosphate, it's a little trickier, right? But it's not that tricky because there's a 2 minus and calcium's a 2 plus. So I can really just jam the two together and I'll get CaHPO4 like that. And again, it's another one of those ones that's trickier to look at because we don't have the parentheses. Now, let's go about naming ionic compounds. Okay. Now, remember I said there's type 1 and there's type 2. Here's the difference between type 1 and type 2 metal ions. Type 1, you don't write charge. Don't write charge in the name. For type 2, we write the charge in the name. And by tradition, we write it in Roman numerals. So write the charge in the name. Now, I don't really need to talk about monatomic and polyatomic. We've already talked about those. You just write their names for those. So let's look at sodium bromide, right? Sodium and bromine. So this would be sodium bromide like this. You can have a space in between or not. Sodium is a type 1. It's in group 1. And bromine is bromide, becomes bromide. So you just write the name. And so that's actually how you name it. You just write it, right, and you have the name. Now, you do that with all ionic compounds. You write the cation name and then the anion name. And then here's the difference. If it's type 2, you have to write the charge in the name. So, for example, this is chromium, Cr. So you know you can write the name chromium. I know it's not type 1. The reason I know it's not type 1, again, going back to my periodic table, chromium is in the middle of the periodic table. And remember, the type 1s are these groups that I marked here and here. Since it's not one of them, I have to include the charge. Now, I don't know what the charge is yet. Okay, so it's chromium. I'm just going to put the parentheses here like this. And then it's bromide. Now what I have to do is I have to figure out what the charge is. And this is how I generally tell people how to do it. Okay, draw a line between the two. And bromide is -1, so it's -1 times 3. So the left side of this line I drew in the middle and the right side have to be the same, except different signs, right? So this right side is -3. That means the right side has to be plus, or the left side has to be +3. So now this is chromium 3+. That's its charge. 1, 2, 3, and we write it as a Roman numeral. Okay, so let's do this one. Okay, and what do, right? You write the name of each ion, and iron, again, going back to my periodic table, it's really helpful to have a periodic table around. You look at here, iron's right in the middle. It's not a type 1, so you're going to have to leave space, right, for its charge. So I'm back to here, and so all you have to do is write iron. leave the space for its charge, and then you have to recognize this polyatomic ion. Again, there's no parentheses, so it's kind of on you to recognize that that's sulfate, okay? Again, the anion name, you just write it. It's pretty straightforward. Now we have to figure out the charge, and this is what I want you to do. I'm going to pause the video. You look at the charge on the right, and remember, it's sulfate. You have to look that charge up, and then you have to balance that with the charge on the left. Okay, so sulfate is 2 minus. That means the iron has to be 2 plus. And so now it's iron 2 sulfate. Now we're going to do this aluminum, right? So we're going to say aluminum. Aluminum or aluminium. And then aluminum, if we look in our periodic table, again, always back to that. Here's aluminum. It is one of the type 1s, so we don't need to write the charge. So I'm going to just go like this. Aluminum, I don't need to leave the space, and then I have to name this ion. Now this is hydrogen phosphate. Should sound familiar. So that's it. That's how you name and write the formulas for ionic compounds. Now I'm going to give you a couple more examples, and then because I want to do, more examples is better. I want to show you a couple other tricks. Okay, so here we go. Copper 2 nitride. I want to write the formula for that. The first thing you have to do is you have to write the formula for the ions. So that's copper, Cu, and then 2 plus. Copper is one of the, and because of the parentheses there, you know it's one of the type 2s, right? That's just telling you what the charge is. There's nothing to look up. So from the name, it's real easy. If you're alert, you just say, oh, it's copper 2, so you write copper 2, symbol, plus 2 plus. And then nitride, you have to recognize as being one of the monatomic ions. And so that's N3 minus, like this. Okay? So now when you write the formula, you're going to take those charges and cross them. You say Cu3N2. So that would be copper 2 nitride. Now, let's write the name for this one. And this is a trick, and it works most of the time, okay? Remember what I told you before, is you got to draw a line in between and calculate the charge on the right, calculate the charge on the left. So I'm going to do that. Draw a line in the middle. Iron, I don't know what its charge is, okay? But phosphate, is 3 minus, so it's actually minus 6. On the left side, I actually have 3x, like that, because there's 3 of them. I don't know the charge of iron, and so I know that there's 3 of them. So 3x, right, and that's supposed to be the same as 6, so x has to be 2. So this is actually iron 2 phosphate. So that is definitely the harder way to do it, but it will get you the correct answer every time. Now, regardless of how I got that number, you see the structure of the name is the same. So you can still write iron 2 and you can still write phosphate. And if there's partial credit, at least you get some credit for that, right? So here's the deal, though. The simple way to do it is to recognize, where did these numbers come from? These numbers, right, were the charges of the ions. And so you knew indirectly, right, that the iron was 2 plus, and you could have just gotten that directly from the formula because this is telling you it's 2. And then phosphate will always be minus 3. So there you go. That's how you name ionic compounds or write their formulas from their names.